Hi guys, today we're going to be talking about Cambridge A level for the mathematics, October November 2021, paper 3. It's a further mechanics paper. So we will start now. For the first question, we have a light elastic string of natural length A. So this will be our natural length, and the modulus of elasticity is 3 mg. So this is our lambda. It's fixed to a point O on a smooth horizontal plane, and a mass m is attached to the other end, and it moves in a horizontal circle with center O. The speed of p would be sub 4 over 3 GA. So we have a horizontal circle like this, and the center O is here. So when the object is here, when the particle p is here, this would be the elastic string. And now let's draw the forces on the particle. So we have its weight, we call it mg. We have the tension here, and since it's on a horizontal plane, we will have the reaction force, the normal reaction force. But in this question, we are not going to look at these two forces. We're not going to care about these two. We'll be focusing on the tension itself. Alright, so for the horizontal force, there's only the tension, right? So we know that in a circle, there would be a centripetal force, and the centripetal force would be the net force. And in this case, it's just the tension. So we can write T equals to, how do we find for the centripetal force? It's mv squared over r. And for the tension, we can write it as, okay, sorry, let's backtrack a bit. So for the centripetal force, we have mv squared over r. And for the tension, we have lambda x over L, where x is the extension and L would be the natural length. So we can now sub in the data that we have. So m would remain as m. V squared would be 4 over 3 GA sub and square, and R would be this length, which is the natural length plus the extension. So we have A plus X. And now lambda would be 3 mg, X would remain as X, and L would be A. So now we can start simplifying this to find for X. So we can cut this off. And now we have 4GA over 3 times A plus X on the left hand side. And for the right side, we have 3gx over A. And we can cancel the g off. So now we have 4a times A equals to 3x times 3 times a plus x. Alright, so the left side would be 4a squared, and the right side would be 9ax plus 9x squared. And since we want to find for the extension, which is x, we can arrange it into this form. 9x squared plus 9ax minus 4a squared equals to 0. And we factorize this, we would get 3x minus a and 3x plus 4a. So x would be 1 over 3a, and x would be negative 4 over 3a. And we know that extension should be a positive value, so we would reject this. And 1 over 3a would be our final answer. Question 2. A particle P of mass m moves along a horizontal straight line with acceleration a given by a equals to v times 1 minus 2t squared over t. So we need to find an expression for v in terms of t and an arbitrary constant. So we know that a equals to dv over dt, right? And in this case, we would have the terms v and t. So this would be the formula that we are using. So dv dt equals to v times 1 minus 2t squared over t. Alright, so now we will need to integrate v and t separately. So we can move v to the left side and move dt to the right side. So we have 1 over v dv equals to the integration of 1 over t minus 2t times dt. So we basically take this part and we separate them. Alright? Now we know that the left side would be ln modulus v, and the right side would be ln modulus t minus t squared plus c, where c is a constant that we will need to find later. And we know that the t value is the time, so it will only be a positive value. So we can ignore this, right? So we have ln modulus v equals to ln t minus t squared plus c. And modulus v would be e to the power of ln t minus t squared plus c. And we will need to separate this thing into a few terms. So we have this, which is just t, times e to the power of negative t squared times e to the power of c. And we know that c is a constant value, it's not a variable. So this whole thing would just be a constant value. So we can write it as, let's say, a big letter A, right? We don't have to we don't have to keep it in this form. So it doesn't look that bad. And we know that the question wants an arbitrary constant. So changing it to this form is what the question wants. So a times t times e to the power of negative t squared. And v can be equal to positive a times t times e to the power of t squared, sorry, negative t squared, or v can be equals to negative a times t times e to the power of negative t squared. So this would be the two answers. Okay. For part B, given that a equals to 5 when t equals to 1, find an expression in terms of m and t for the horizontal force acting on p at time t. So we can first find for the velocity value. So when a equals to 5, t equals to 1. Sorry. So v would be, sorry, we need to sub it back into this equation here, right? Let me copy it so that we can see it clearly. Okay, so a would be 5, v would be the one that we have to find, and 1 minus 2t squared would be 2, since t is 1, over 1. So v would just be negative 5. And we know that v is a negative value, so we would need to use this, right? So use the second equation. How do I know that I need to use the second equation? See, in the first equation, all these values should be a positive number. And that's why we need to use the second equation to get a negative value. So now we can find for the value of a. So v is negative 5 equals to negative a times t, which is 1, times e to the power of negative 1. So a would be 5e. And now we can find for the horizontal force. So F equals to ma, and a would be this value over here. So we have F equals to m times a, which is v times 1 minus 2t squared over t. But v is equals to negative a t e to the power of negative t squared. So we have to sub this in as well. So we have negative 5e times t times e to the power of negative t squared times 1 minus 2t squared over t. So we can cancel off the t, and we have F equals to negative 5m times e to the power of 1 minus t squared times 1 minus 2t squared. And if you want to make it nicer, we can also write it as 5m times e to the power of 1 minus t squared times 2t squared minus 1. So this would be our final answer. Question 3. A light elastic string has natural length A and modulus of elasticity of 12 mg. One end of the string is attached to a fixed point O and the other end is attached to a particle of mass m. It hangs in equilibrium vertically below O, but after that it's pulled vertically down and released from rest. So from rest means that V equals to 0 with the extension of the string equal to E. So E would be the extension when it's pulled vertically down. In the subsequent motion, the particle has speed sub2 when it has ascended a distance of 1/3 of a. So the particle hangs like this. When it's pulled down, this is V equals to 0 when it's pulled down, and the extension is equals to E. So we have the natural length A and the extension E. And in the subsequent motion, the particle has speed equals to sub2 when it has ascended a distance of 1/3 a. So this distance here would be the distance when it's pulled down minus 1/3 of a, right? Because it has ascended a distance of 1/3 a. That means whatever here minus 1/3 a. So we have a plus e minus 1/3 of a. Alright? So we need to find e in terms of a. Okay, so we can just compare these two situations. And we know that there is a change in the energy, like the elastic potential energy, gravitational potential energy, and the kinetic energy are changed. So the energy loss would definitely be equal to the energy gain. And in this case, whatever that is lost is just the elastic potential energy. And for the energy gain would be the gravitational potential energy plus kinetic energy. Alright? So for the EPE loss, we can just find for, okay, so the formula would be lambda difference in x squared over 2L. Because EPE equals to lambda x squared over 2L. But now that you want to find for the change in the EPE, so whatever that is changed is just this over here. And if you want to find for the change, you just have to find for the change in the x squared. Okay? And for the gravitational potential energy, we have mgh. Kinetic energy, we have half m change in v squared. Okay, so now we can start subbing in the values. So we have lambda as 12 mg times change in x squared. Okay, so initially the extension is e, right? So we have e squared minus, and after it has ascended, we know that it has ascended a distance of 1/3 a. That means the extension would now be e minus 1/3 a. So e minus 1/3 a would be the extension after it has ascended. Okay, so all these things over 2a. And for the GPE gain, we have mgh would be 1/3 of a because it has gone up a distance of 1/3 a. And for KE, it would be half m times sec 2GA squared because initially it has speed of 0, so we can just ignore this. And now let's simplify this equation. So on the left side, we have 6 mg over a times e squared minus e squared plus 2/3 of ae minus 1 over 9 a squared. And for the right side, we have 1 over 3 mga plus mga. So we can cancel off mg, and now we have 6 over a times 2 over 3 ae minus 1 over 9 a squared. And on the right side, we have 4 over 3a. So now we move this a over there. So we have 4. Oh, sorry, we don't have to move it over there. We can just cancel off this, right? So we have 4e minus 2 over 3a equals to 4 over 3a. So 4e would be equal to 2a, and e would be half a. And this would be the final answer. Question 4. We have a uniform lamina AECF. It's formed by removing the two identical triangles BCE and CDF from a square lamina ABCD. The square has side 3a and EB equals to DF equals to H. So we need to find the distance of the center of mass of the lamina AECF from AD and from AB. So AD is this and AB is this, giving our answers in terms of A and H. Okay, so now we can draw a table. So the first column would be the lamina, second column would be their area, third one would be the distance of center of mass from AD, and the fourth column would be the distance of COM from AB. So for the first row, we have the lamina ABCD, which is a square. The second one, we need to minus the triangle, which is BCE, and we minus another triangle, which is CDF. And lastly, we would get the uniform lamina AECF that we want. Alright, so for area of ABCD would be 9A squared. Area of BCE would be half times H times 3A, which is 3 over 2AH. Same goes to CDF. It would be 3 over 2AH. And now let's find for the distance of COM from AD. So for the square lamina, we know that the center of mass would be right in the middle. So the distance of COM from CD would be 1.5A. And the distance of COM from AB would also be 1.5A. Right? So now moving on to BCE. BCE would be this triangle over here. So for the distance of COM from AD, we will need to look at these points. Okay, so this in XY coordinate, right? This would be 3A0. This would be 3A, 3A, and this would be 3A minus H, 0, right? So for the distance of COM from AD, we just have to look at the X coordinate. So we have 3A plus 3A plus 3A minus H over 3. So we have 9A minus H over 3. So we have 3A minus 1 over 3H. So the distance of COM from AD for the triangle BCE, this one, would be 3A minus 1 over 3H. Alright, as for the COM from AB, we would now need to look at the y coordinate. And y coordinate will be 3A plus 0 plus 0 over 3, so it gives us 8. As for the triangle CDF, it would be, this would be 0, 3A minus H. This would be 0, 3A. This would be 3A, 3A. So looking at the x coordinate, we know that this would be A. And looking at the y coordinates, from what we have calculated previously, we know that this is 3A minus 1/3 of H, right? So now we need to look at the lamina AECF. So the area of AECF is just 9A squared minus 3 over 2AH minus 3 over 2AH. So it would be 9A squared minus 3AH. As for the distance of COM from AD, let's call this X bar and Y bar. For X bar, what we do is we multiply this minus the multiplication of this minus multiplication of this, and we would divide the whole thing by the area of AECF. So we have 9a squared times 1.5a minus 3 over 2ah times 3a minus 1/3 h minus 3 over 2ah times a. So this whole thing divided by 9a squared minus 3ah. So we have 13.5a cubed minus 4.5a squared h plus 0.5ah squared minus 1.5a squared h divided by 9a squared minus 3ah. So this would be 27a squared. We multiply this by 2, multiply this by 2, and divide it by a. Right, so we have 27a squared minus 12ah plus h squared divided by 18a minus 6h equals to 3a minus h times 9a minus h over 6 times 3a minus h. So we can cancel this off, and we would get 9a minus h divided by 6. As for y bar, we can see that it's the same thing. This times this minus this times this minus this times this. So we have 9a squared times 1.5a minus 3 over 2ah times a minus 3 over 2ah times 3a minus 1/3 h divided by 9a squared minus 3ah. So this would give us the same answer, which is 9a minus h over 6. Alright, so we have found the answer. Part B. The lamina AECF is placed vertically on its edge AE on a horizontal plane. Find in terms of A the set of values of H for which the lamina remains in equilibrium. So we have this lamina here, and it's placed vertically on this edge. So imagine this is the surface. The black line is the surface, and it's placed vertically like this. So let's say this is the COM. In order for it to remain in equilibrium, we know that it shouldn't pass this line, right? So if the COM is here, let's say here, that's the maximum place that it won't topple, right? If the COM is like here, then we know that obviously this whole plane will topple. So this place here is the maximum COM, the maximum length of the distance of COM from AD that it can be. So we know that this x bar here, the distance of COM from AD, has to be in this range, right? So x bar has to be more than 0 or less than 3a minus h. Because this length here is 3a minus h. Okay, so now we can equate whatever that we found here into this x bar. So we have 9a minus h over 6 less than equals to 3a minus h. So we have 9a minus h over 6 more than equals to 0. So h would be less than equals to 9a. And you have 9a minus h over 6 less than equals to 3a minus h. So 9a minus h less than equals to 18a minus 6h. So we have 5h less than equals to 9a. H is less than equals to 9 over 5a. So we know that h is obviously less than equals to 9a, right? Because this whole thing is just 3a. So definitely h is lesser than 9a. So this is a bit useless. So we just don't care about it. We just reject this. And this is the useful one, the useful info. H less than equals to 9 over 5a. A particle P is projected from point O on a horizontal plane and moves freely under gravity. Its initial speed is u and its angle of projection is arcsine 4 over 5 above the horizontal. At time 8 seconds after projection, P is at the point A, and at time 32 seconds after projection, P is at the point B. The direction of motion of P at B is perpendicular to its direction of motion at A. So we have a projection like this. So it's projected at this place with initial speed of u and the angle of arcsine 4 over 5. So at t equals to 8, we have, let's say, here, the particle is here with its direction of motion like this. This is t equals to 8. And at t equals to 32, let's say it's here, the direction of motion is perpendicular to the direction of motion when t equals to 8. So this is when t equals to 32. So now we have to find for the value of u, and we know that these two are perpendicular. So how do we find for the angle of motion, the direction of motion? We need to find for the velocity of the particle when t equals to 8 and the velocity of the particle when t equals to 32. So we always separate the vertical and the horizontal velocity. So now let's look at A. So at point A, our horizontal velocity Vx would be, okay, let's use this formula. V equals to u plus at. So Vx equals to ux, which is u cos theta plus at. But horizontal, there's no acceleration in horizontal direction. So it's just u cos theta. And we know that from this info, we know that sine theta equals to 4 over 5. So cos theta would be, so this would be our theta. Sine is 4 over 5, so this would be 3. So cos theta would be 3 over 5. Alright, so our Vx would be 3 over 5 u. And Vy is equal to u sine theta plus a would be negative 10 and t would be 8. Why is our a negative 10? Because the acceleration is going downwards. Alright, so since we assume that the upward direction is positive, so our acceleration downwards would be a negative. So sine theta would be 4 over 5u minus 80. Okay, so the direction of motion at point A would be tangent alpha equal to Vy, which is 4 over 5u minus 80 divided by 3 over 5u. So this would be 4u minus 400 divided by 3u. Okay, now let's look at point B. So the horizontal velocity would be the same, 3 over 5u, and the vertical velocity would be u sine theta plus g, sorry, a, which is negative 10, and t would be 32. So this would be 4 over 5u minus 320. So the direction of motion, let's call the angle beta, would be 4 over 5u minus 320 divided by 3 over 5u. So this will give us 4u minus 1600 over 3u. So now we have the direction of motion at both points, and we know that they are perpendicular to each other. So we can just take this times this equals to negative sorry, equals to negative 1. Why is that so? Because m would be tangent angle, right? And when the gradient is perpendicular to each other, we have m1 times m2 equals to negative 1, right? So same goes to this case. Tangent alpha and tangent beta, we can treat it as the gradient of the direction of motion. So tangent alpha times tangent beta would give us negative 1. So we have 4u minus 320 over 3u. Sorry, this would be 400 times 4u minus 1600 over 3u equals to negative 1. So we have 16u squared minus 6,400 U minus 1,600 U plus 640,000. Yeah, 640,000 equal to negative 9U squared. So simplify this, we have 25U squared minus 8,000U plus 640,000 equals to 0, and U squared minus 320U plus 25600 equals to 0. Factorize this, we have U minus 160 squared equals to 0. So U would be 160. And that's our answer here. Question 6. A particle P of mass m is attached to one end of a light extensible string of length A. The other end of the string is attached to a fixed point O. P moves in a complete vertical circle about O with the string top. The points A and B are on the path of P, with AB a diameter of a circle. OA makes an angle theta with the downward vertical through O, and OB makes an angle theta with the upward vertical through O. The speed of P when it is at A is set 5 ag. So we have a vertical circle. Okay, and this is the vertical. This would be the center O, and this would be A, this would be B. Alright, so when it's at A, it has a speed of set 5 ag, and the force would be a tension towards the center, and let's say this is a particle, so there will be a downward force, which is the weight. Let's call it mg, but we have to resolve it in the direction of the motion. So this would be, okay, first this would be theta, so this would be theta, and the force away from the center would be mg cos theta. Okay, obviously there's another direction here which we have to resolve, but I don't think it's needed in this question, so let's just ignore it for now. And when the particle is at B, same thing, it has a tension force of Tb towards the center of the circle, and this is angle theta, so the weight would be mg, and when we resolve it in the direction of the circle perpendicular to the circle, this would be one of the forces, and another one would be here. So this would be theta, and this is mg cos theta. And same thing, we don't really need this force over here for this question, so I'm just going to remove it. Okay. So we need to find the value of cos theta. And how do we do it? First, we have the information about the speed at point A. So we can find the centripetal force using this information. So we have centripetal force equals to TA minus mg cos theta. Remember, the centripetal force is always the resultant force, alright? And it's always directed towards the center of circle. So it would be TA minus mg cos theta. And the formula for centripetal force is mv squared over r. So mv squared would be sub 5ag squared over r would be the length of the string, which is a. And TA is just TA, this is the one that we have to find, minus mg cos theta. So the left hand side we have 5mg, and the right hand side we have TA minus mg cos theta. So TA is equal to mg times 5 plus cos theta. And now we will need to find for the tension at point B, this force over here, but we do not have any info to find for the centripetal force. So what we have to do is we need to use the conversion of energy to find for the speed of the particle at point B. So we have the GPE gain will be equals to the KE loss. So from point A to point B, let's say it goes like this, we know that the gravitational potential force, the gravitational potential energy is increasing and the kinetic energy is decreased. So we need to find for the vertical height. So we know that this is A, so the vertical height over here would be A cos theta, and is the same here, A cos theta. So we know that the height increase is 2A cos theta, right? So the GPE gain would be mg times 2A cos theta. And for the kinetic energy, we have half m times the change in v squared. So the change in v squared would be v squared at A minus v squared at B. So the v squared at A would be sub 5ag squared minus vb squared. And vb squared would be the one that we have to find later. So now we simplify this thing. We can cancel off the m. And we have 2ag cos theta equals to half times 5ag minus vb squared. So 4ag cos theta equals to 5ag minus vb squared. So vb squared equals to 5ag minus 4ag cos theta. So now we have the speed of the particle at B. So we can find for the tension at B using the centripetal force. So at point B, centripetal force is directed towards the center of circle. So it would be TB plus mg cos theta. So our centripetal force equals to TB plus mg cos theta. And centripetal force is mv squared over r. So m times v squared, which is 5ag minus 4ag cos theta over a. So TB remains as TB and plus mg cos theta. So for the left side, we have 5mg minus 4mg cos theta. And for the right side, we have TB plus mg cos theta. TB would be equal to 5mg times 1 minus cos theta, right? And from the question, we know that the ratio of the tension in the string when P is at A to the tension in the string when P is at B is 9 to 5. What does that mean? It means that TA over TB equals to 9 over 5. Alright, so this means that TA is equals to 9 over 5 TB. So we can use this info. TA equals to 9 over 5 TB. So TA would be mg times 5 plus cos theta time equals to 9 over 5 times TB, which is 5 mg times 1 minus cos theta. So we can cancel off the mg, cancel off the 5. So we have 5 plus cos theta equal to 9 minus 9 cos theta. So 10 cos theta equals to 4 and cos theta equals to 2 over 5. And that's it. Part B. Find in terms of A and G the greatest speed of P during its motion. So the greatest speed occurs at the lowest point of the vertical circle. Why is that so? Because greatest speed means maximum KE, and we know that energy conversion, energy doesn't disappear or is not created. So it can only be converted from another form of energy. So maximum KE is converted from the GPE. So this also means that we have minimum GPE during maximum KE. So minimum GPE means that it's at its lowest point. So let's draw a circle again. This is the vertical. This is point A. So at the lowest point, what is the height? What is this height over here? Oops. Okay, we know that this whole thing is A, right? And this thing is A cos theta. So this thing here would be A minus A cos theta. Alright, so we can just use this formula. The GPE loss equals to the KE gain. So GPE loss would be mg times A minus A cos theta, because it's the height difference, right? So KE gain would be half m times the maximum speed square, so v square, or we call it v max square if you want, minus at A, the speed is cert 5 ag, right? So we minus square of cert 5 ag. So we can cancel off the m. We have g times A minus, okay, cos theta is 2 over 5 as we found in part A. So minus 2 over 5a equals to half times v max square minus 5ag. So the left hand side would be 3 over 5ag equal to half v max square minus 5ag. So v max square minus 5ag would be equal to 6 over 5ag, and v max square equals to 31 over 5ag, and v max equals to 31 over 5ag. So this would be the greatest speed of p. Question 7. The smooth vertical walls A, B, and CB are right angles to each other. Particle P is moving with speed u on a smooth horizontal floor and strikes the wall CB at an angle alpha. It rebounds at an angle beta to the wall CB. The particle then strikes the wall AB and rebounds at an angle gamma to that wall. The coefficient of restitution between each wall and P is E. Show that tangent beta equals to E tangent alpha. Okay, so for part A, we would first look at this collision. We don't care about this first, okay? So for the first collision, we can have two equations. So the one perpendicular and one parallel. So for the one perpendicular to the wall, we have, okay, first let's call this v, okay? The speed after the first collision would be v. So the one perpendicular to the wall is u sine alpha, sorry, v sine beta equals to negative e times negative u sine alpha. So v sine beta would be equal to eu sine alpha. So this would be our first equation. And for the one parallel to the wall, we have V cos beta equal to U cos alpha. The speed parallel to the wall doesn't change. Okay, so this would be the second equation. So we can use the first equation divided by the second equation, and we would get E sine beta over V cos beta equals to EU sine alpha over U cos alpha. And from this, we have sine beta over cos beta, right? And this would give us tangent beta. So the right side, we would also get E times tangent alpha. So this would be the equation that we get. And for part B, express gamma in terms of alpha and explain what this result means about the final direction of motion of P. So now we have to look at the second collision. This one, this collision. Alright. So let's call the speed after the second collision W. So same thing. We can have an equation parallel to the wall and one perpendicular to the wall. So for the one parallel to the wall, the parallel speed doesn't change. So W cos gamma equals to V cos. Okay, I forgot to talk about this. So what is this angle here? We know that this is a right angle, right? So since this is a right angle, this angle here would be 90 minus beta. Alright? So V cos 90 minus beta. And we can simplify this to V cos gamma equals to V sine beta. Cos 90 minus x can be written as sine x. Sine 90 minus x can be written as cos x. And tangent 90 minus x can be written as 1 over tangent x. Okay, so these are the three formulas that we have to know in order to solve this question, sorry. So for the perpendicular to, for the direction perpendicular to the wall, we have W sine gamma equals to negative E times negative V sine 90 minus beta. So we have W sine gamma equals to EV cos beta. Let's call this equation 3 and equation 4. So 4 divided by 3, we have W sine gamma over W cos gamma equals to EV cos beta over V sine beta. So we have tangent gamma equals to E over tangent beta. So from part A, we know that tangent beta equals to E times tangent alpha. So tangent gamma will be equal to E over E times tangent alpha. And now we know that tangent gamma is equals to 1 over tangent alpha. And from this formula, we know that tangent 1 over tangent alpha is equals to tangent 90 minus alpha, right? So we have tangent 90 minus alpha. And now we know that gamma is equal to 90 minus alpha. So this is what the question means by find the value of gamma in terms of alpha. So what does this say about the final direction? This says that the final direction is parallel to the initial direction. How do I know it's parallel? Okay, so we know that this is a 90 degrees, right? So gamma is 90 minus alpha, which means alpha plus gamma equals to 90. So this angle right here would be alpha. Alright? And you can see that this and this are parallel. So this angle and this angle, if they are the same, that means they are the same, right? So these two directions are parallel. And that's why we know that the final direction is parallel to the initial direction. Part C. As a result of the two impacts, the particle loses 8/9 of its initial kinetic energy. Given that alpha plus beta equals to 90, find the value of E and the value of tangent alpha. So we have the info about the kinetic energy loss. So we can use that info to find for the values. But before that, we need to know what is the final speed in order to know the value of the kinetic energy loss, right? So we need to know what W is. So now we can take the third equation, square it, plus the square of fourth equation. So we have W squared cos squared gamma plus W squared sine squared gamma equals to V squared sine squared beta plus E squared V squared cos squared beta. We can factorize the W square out, so we have cos square alpha plus sine square alpha equal to V square times, never mind, let's not do this, times V sine beta square plus EV cos beta square. So cos square plus sine square equals to 1. So we have W square equals to, from part A, we know that V sine beta equals to EU sine alpha, and V cos beta equals to U cos alpha, right? So we can write the right hand side as EU sine alpha square plus EU cos alpha square. So same thing, we factorize EU square out. So we have sine square alpha plus cos square alpha, and this is equal to 1. So W square equals to EU square. So W equals to EU. So now that we have the value of W, we can start using this information. Alright? So the final kinetic energy, which is half mW square, is equal to 1/9 of the initial kinetic energy, which is half mu square. So W equals to EU. So we have half m times EU square equals to 1/9 times half mu square. So we can cancel half m out and u square as well. So we have E square equals to 1/9. So E is 1/3. So we have found the value of E. And now we have to find for tangent alpha. So we look back at part A. We have this equation. Tangent beta equals to E tangent alpha. So tangent beta equals to E tangent alpha. And we know that alpha plus beta equals to 90. So beta would be 90 minus alpha. And E is 1/3. So tangent 90 minus alpha would be 1/tangent alpha from the formula that I gave just now. So the right hand side is still 1/3 tangent alpha. So tangent square alpha equals to 3. And tangent alpha equals to sec 3. So this would be the value of tangent alpha.